This is lesson 4 for the factoring and rational expressions unit. So to simplify a rational expression, so rational, you see the word ratio, so we're looking at fractions, really, is you want to completely factor the numerator and denominator. That's the first step. I wrote too big. And then the second step is to cancel the expressions that are identical and reduce GCFs if necessary. So, cancel. All right. So it's very similar to what we did in the last lesson, except the factoring part wasn't done. So we'll have to do the factoring first and then do what we did in the last lesson. So let's take a look at this first example here. And I'm gonna factor the numerator. Again, you always look for a GCF first. So in the numerator, I do not have a GCF. And we want to find two numbers that when we add them, we get 3, and when we multiply them, we get -10. So those two numbers are 5 and -2. In the denominator, they add to 8 and they multiply to 15. That would be 5 and 3. Okay. So we would cancel out identical expressions, one in the numerator, one in the denominator, and then that leaves us with our answer. Okay, example 2. Again, for all of these, if you want to pause, I'm going to kind of zip through them, not go too fast, but if you want to pause and try it on your own and then check to see what I did, that might be a good thing to look at here. So for this one, in the numerator, we need two numbers that add to -4 and multiply to -5, and that would be -5 and +1. In the denominator, this is the difference of two squares, so it would be x plus 5 and x minus 5. So our x minus 5 expressions cancel, and we are left with x plus 1 over x plus 5. Next example. There's nothing to factor in the numerator, so we are just going to leave that alone. In the denominator, the factoring would be x minus 6 and x minus 10. So those cancel. And remember, you can't just leave your numerator blank. There's a 1 there. It's invisible, but it's there. 1 over x minus 10. Example 4. In the numerator, our factoring would be x plus 9 and x minus 3. There's nothing we can factor in the denominator. So the x plus 9s will cancel. Now in this case, it would be x minus 3 over 1, but when the 1 is in the denominator, you do not have to write it. Okay. Example 5. Two numbers that add to 10 and multiply to 25 are 5 and 5. Add to 13, multiply to 40, 5 and 8. Okay, now here, you can only cancel out one in the top and one in the bottom. This one won't cancel as well because there's not another one in the denominator for it to cancel with. So x plus 5 over x plus 8. Okay, example 6. Looks like we do have some greatest common factors here. In the numerator, 2. So that leaves us with x squared minus 16x plus 63. In the denominator, we can factor out a 4. So x squared minus 12x plus 35. Okay, now for our trinomial factoring. If you want to reduce the 2 and the 4 here, you can. 2 over 4 reduces to 1/2. So that would leave us with, we don't have to write this 1 now. X minus 9 and x minus 7. And the denominator, we'd still have that 2. That didn't go away. And then x minus 5 and x minus 7. So those cancel. And that leaves us, this is one of those ones where we have this or that. I'm going to have to come down here. I wrote too big again. So either x minus 9 over 2 times x minus 5. Or, again, if it's multiple choice, it might look like this, or maybe they'll distribute that 2, and you'd get 2x minus 10. So make sure that you would recognize both of those. Okay, that's page 1. We have more. Example 7. Again, just factoring like we did in previous lessons, so I'm hoping this is going a lot better for you. If not, you should come see me. So x minus 9, x plus 9. In the denominator, we have a GCF of 3. And that's all we can do in the denominator. So x minus 9 cancels, and it's x plus 9 over 3. Okay. Example 8. In the numerator, I have a GCF of 4x. So then that gives us x squared minus 2x minus 15. In the denominator, we have a GCF of 6, which leaves us with x squared plus 8x plus 15. Okay, I'm going to reduce this 4 and the 6 right away. 4 over 6 is 2/3. So now I have that 2x, and then here this factors to x minus 5 and x plus 3. In the denominator, I still have that 3, and then this will factor to x plus 5, x plus 3. So those cancel. These do not. They're not identical. One's a minus, one's a plus. So it may look like this. 2x times the quantity x minus 5 over 3 times the quantity x plus 5. Or maybe they'll distribute and get 2x squared minus 10x over 3x plus 15. Both answers are correct. And personally, I would accept either one. Okay. Example 9. In the numerator, we have a GCF of 2. So x squared minus 10x plus 9 and x minus 1. So 2, and then this factors to x minus 9, x minus 1. Those cancel. So our answer is 2 times the quantity x minus 9, or 2x minus 18. Example 10. Nothing to do in the numerator, nothing factors there. In the denominator, I have a GCF of negative 3. So that would leave me with x plus 5. So these cancel, and it leaves me with negative 1/3. Remember, just a side note, negative 1 over 3, negative 1/3, and 1 over negative 3 are all the same thing. Okay, our last two examples here. Example 11. what we're gonna do is this denominator looks a little crazy. First thing I'm gonna do is distribute this x. Okay, so let's factor the numerator while we're at it. So that would be x minus 10 and x plus 6. In the denominator, when I distribute the x, I get x squared plus 11x plus 30. Now it looks more familiar. So now I'll factor that. Just carry the numerator along here. And then when I factor this, it's x plus 5, x plus 6. So those cancel. And we are left with x minus 10 over x plus 5. Okay, similar deal here with example 12, but this time it's in the numerator. So let's distribute that, x squared plus 12x plus 20. And if you want to factor the denominator right away, there's no problem with that. The numerator, when I factor it, it's x plus 10 times x plus 2. When we factor the denominator, x plus 10, x minus 7, which leaves us with x plus 2 over x minus 7. Okay, that's lesson 4.